Hello, and this is a Bullis Student Tutors video about Hardy-Weinberg Equations, which is a model created by these two scientists, Hardy and Weinberg. So, what is Hardy-Weinberg? It states that allele and genotype frequencies in a population will remain constant from generation to generation in the absence of other evolutionary influences. What this basically means is that the population can evolve, it can't change. So, this is called Hardy-Weinberg equilibrium, and there's 5 factors that you need for this to happen. First, you can't have mutations. Second, you can't have a small population. You can't have selective mating, you can't have gene flow, and you can't have environmental change or natural selection. I'm not going to go into too much detail on these, as the focus of this video is more going to be about solving Hardy-Weinberg problems, but these are important because there's never a population in the wild where you're not going to have any sort of natural selection or any sort of evolution whatsoever. However, it's still pretty important as a model, as you can see how much a population deviates from the Hardy-Weinberg equilibrium and what factors are causing that to be the case. So now, let's look at the equations for Hardy-Weinberg. There's 2 parts to the equation. First, it says p plus q equals 1. Second, p squared plus 2pq plus q squared equals 1. These don't require such complex math. More often where students will mess up is they don't know the variables, and this can lead to a lot of careless mistakes when all the work was done correctly. We'll just review them really quickly. So p is the frequency of the dominant allele. Don't confuse this with p squared, which is the frequency of the homozygous dominant trait. 2pq is the heterozygous frequency. That means individuals that have one big allele and one little allele, one dominant, one recessive. And then we have q, which is the frequency of the recessive allele. Again, don't confuse this with q squared, which is the frequency of the recessive trait. A lot of the time, students will solve for q when the problem asks to solve for q squared, or solve for p when the problem asks to solve for p squared. One good thing to do would be to make a Quizlet or to make flashcards if you don't know these variables yet, because this is one of the most common places students make mistakes. Now we can look at an example problem. So this problem states, in corn, purple kernels are dominant to yellow, and a random sample of 100 kernels is taken from a population in Hardy-Weinberg equilibrium. It is found that 9 kernels are yellow and 91 are purple. What's the frequency of the yellow allele? So right now you can pause the video. I'll work out the solution in a couple seconds. Pause the video if you want to try it yourself. Alright, so let's work out the solution for this problem. The first thing we can do is figure out what the variable is they want us to solve for. So that's the frequency of the yellow allele. Like they tell us in the first sentence, yellow is the recessive trait, purple is dominant to yellow, which means that the frequency of the yellow allele, remember it's the allele, not the trait, so that would be Q. And what we can see is that they tell us that 9 kernels are yellow and 91 kernels are purple. We can't really do anything with them telling us 91 are purple, since that's equivalent to p squared plus 2pq, and just by looking at it, we have no way of knowing if that's going to be the homozygous dominant or the heterozygous, because it's going to be a mixture of both. But what we do know is that q squared is equal to, the number of yellow kernels is 9. And make sure you write q squared as 0.09. Remember, it's a frequency, not a number. This problem is pretty simple. All we need to do is find q, which is what we want to solve for, is to just take the square root, and that'll give us q equals 0.3. Alright, so to finish it off, we're just going to look at some tips and tricks to make solving these problems a little bit easier. The first is, like I said before, to really know the variables well. First is about q squared. Q squared is usually what they're going to ask you to solve. Usually what you can solve for first. Because q squared, the way I like to think about it is, it's the only thing that you can know just from looking at an organism. You can never tell if an organism has 2 dominant alleles or 1 dominant and 1 recessive just by looking at it. However, if you see that the organism has the recessive trait, then you immediately know that it has 2 recessive alleles, and that'll give you q squared right off the bat. Then you also need to know what they're asking for. Like I said before, make sure not to solve for the wrong variable. That would be really bad, because it means you'll have done all the hard work of doing the math right, but getting the wrong answer. And then finally, make sure you answer the question right, because they can ask you to give it as a percentage, a number, or a frequency. So frequency is the default answer. It's in between 0 to 1. If you want to turn it into a percentage of the whole, then multiply it by 100, and if you want to find a number, just take the frequency and multiply that by the total number of organisms in the population. This was a Bullis Student Tutors video, and I hope that was helpful.